The crank of a slider crank mechanism rotates clockwise at a constant speed of 300 rpm, and the crank is 150 mm and the connecting rod is 600 mm long. So we have to find out the linear velocity and acceleration of the slider, as well as angular velocity and angular acceleration of the connecting rod at a crank angle of 45 degree from inner dead center position. So now the AB is given as 150 mm, BA is given as 600 mm, and angle BOA is equal to 45 degree from inner dead center. So before space diagram, we have to take a scale, and that is 150 mm is equal to 3 cm. So according to this scale, we will make this space diagram. So in this you can see this is angle is 45 degree. So we will mark, and as per scale we will take this is 3 cm. Okay, and the second one is connecting rod, that is 12 cm, and this is the slider and ground for the slider. This is connecting rod. So space diagram completed. Again, in this question we have given input 300 rpm clockwise direction, so we can find out the angular velocity of the link BO, and that is 31.4 radian per second. Now as we got the angular velocity, so we can find out the velocity of the link BO. So by multiplying angular velocity and length of the link, we can find out the velocity of link BO, that is omega BO into BO. So this is equal to 4.71 meter per second. So we have velocity of input link, also the direction. So for another links we have to make the velocity diagram, so we'll go for velocity diagram, and for that we have to choose the particular scale. So we have taken 4 meter per second is equal to 4 centimeter. So before now we have to mark the fixed points, that is O and G, and we will shift the velocity, input link velocity, in the given direction. So that is 4.7 centimeter as per the scale. So now this is point B, and this is the direction of VBO. Now with respect to B point, the A can move in like this or this direction, so we just predict, okay, like this or in this. So we will shift both the direction to the point B with the help of set squares, like this. And secondly, the slider can move in horizontal direction, so again we will predict like both the direction, and we will shift to the velocity diagram. So VAG and VAG, so we will shift this direction to this velocity diagram. So by shifting it, you can see there is a two velocities, and the intersection of both velocity will be A. So that is point A, and this is VAB. Okay, so this prediction is right, wrong, and this is VAG, and this is right, and this is wrong. So we have completed the velocity diagram, so we can measure, and after measuring we can reconvert that to the proper scale. So this is 3.4 centimeter, so this is equal to 3.4 meter per second. So also according to the prediction, we got the right prediction, and the omega AB is velocity per length, and that is 5.66 radian per second in counterclockwise direction. Next, that is VAG. So by measuring, this is equal to 4 centimeter, so simply this is 4 meter per second. So we got all the values of the velocities of the links. Now we'll go for acceleration diagram, and we'll choose the proper scale. So before that we have to find out some components values, that is link input link BO. So there is a two component, radial and tangential. So in this radial component is simply velocity square per length. So this is equal to 147.89 meter per second square. But in this question there is no angular acceleration, so this is equal to 0. So tangential component of BO will be equal to 0. And for link AB, the radial component we can find easily with the help of velocity square divided by length, so that is 19.26 meter per second. But the angular acceleration of the link AB is not given, so we cannot find out. Again, there is no component for slider, there is only acceleration. There is no radial and tangential component for the slider. So now we'll go for the scale according to the radial component of the input link. So we have chosen the 20 meter per second square is equal to 1 centimeter. So in this question we will mark the fixed point, and in this you can see for radial component we have to go from B to O. B to O. The center point for OB is O, so B towards O. So you can see we have taken the direction from B to O, and again the shifting the same from B to O. So according to the scale, this is 7.39 centimeter. So we'll mark this, and from B to O, that is radial component of acceleration for this input link, that is for BO. But as you can see, there is no tangential component, so the radial component will be final acceleration of the BO, and we will make this a simple line. Now next is radial component. So again I will say that from A to B, for link AB the center point is B, so A towards B. So again we will go like this from A to B, and this is the radial component. The value is 19.26. so according to scale, that is 0.96 centimeter. 0.96 centimeter. So we'll mark this 0.96 centimeter on that. So this is the radial component of link AB, and the values of this is 0.96 centimeter. Now we'll go for tangential component. As we don't have any magnitude, so we will go for only direction 90 degree to the radial component in both direction. So AB is completed. Now we'll go for the slider, and slider have no component, only single acceleration. So we will go on horizontal direction on this. So you can see the intersection, that is point A. This is acceleration of AG, this is tangential acceleration of AB, and we will just call, this is acceleration of AB. So acceleration portion is completed. By measuring we can find out the values of different acceleration. So this is tangential acceleration of AB, that is 5 centimeter. So with the help of scale, this is 100 meter per second square. So this is 100 meter per second square. Length AB is 0.6. So we can find out angular acceleration of link AB. So that is 166.66 radian per second square. Okay. Also we can find out the acceleration of the slider by measuring, that is 5.1, and this is 102 meter per second square. And last one, that is connecting rod AB. So that is by measuring, this is 5.2 centimeter, and this is 104 meter per second square.